me show you one interesting usage of the squeeze theorem. We want to show that the limit of this expression, sine of x divided by x, is equal to 1 when x approaches 0. We cannot use direct evaluation because for x is 0, the denominator is 0, and this fraction does not exist. If we sketch the graph, or if we evaluate for x close to 0, then this fraction indeed approaches this value. This can be shown by an interesting graphical method. We will use the following picture. Imagine the unit circle, and here the angle will be x. Then, if this is 1, this distance is cosine of x, and this is sine of x. And then we can consider the area of 3 regions. First, this triangle, if we denote the points O as origin, A and B, and then we consider a vertical line at the point 1, 0, and then this point will be called C, and this point will be denoted capital T. Then we have these 3 regions, this triangle, this segment of the circle, and this large triangle. So the area of the triangle OAB is definitely less than this part of the circle. If we take the whole circle, the area is pi r squared. If we consider r is equal to 1, then the area is pi. And if we have the angle x, then the area is proportional to x. For x is 0, the area is 0, and for x the whole circle, 2 pi, the area is pi. So for a general x, the area is 1/2 of x. So this is the part of the circle, let's call it OCB, and this is definitely less than the triangle, the area of the triangle OCD. But the area of a triangle is 1/2 of the product of the base times the height. So we have 1/2. Base is cosine of x, and the height is sine of x. The area of this part of the circle, OCB, is x/2. And the area of the triangle OCD is again 1/2 of the base, which is 1, times the height, and the height must satisfy that the height divided by 1 is tangent of x. So this must be tangent of x, because this is 1. Now we want to manipulate this condition a little to find some useful result to compute this limit. First, we can multiply by 2, to get rid of the fractions, and we get cosine of x times sine of x is less than x is less than, and tangent can be written as fraction sine of x divided by cosine of x. Now we can divide by sine of x to get cosine of x is less than fraction x divided by sine of x is less than 1 over cosine of x. And now for x approaching 0, cosine approaches 1, and as cosine approaches 1, that 1 over 1 is 1, so this fraction approaches 1 as well. And now we can use the squeeze theorem, because we have some complicated function with this lower bound, this upper bound, and these two functions, both of them go to 1. So the limit of this must be 1. This goes to 1 as well. And this finishes the proof that this limit is equal to 1. For x close to 0 but different from 0, cosine is slightly less than 1. You see, you are somewhere here. And if we consider 1 over a number that is slightly less than 1, then this is slightly greater than 1. So we could say that this goes to 1 from the left, this goes to 1 from the right. Unfortunately, from the squeeze theorem itself, it is not possible to deduce whether this goes to 1 from left or right. And if we sketch cosine here, and if we sketch 1 over cosine, then we have a function like that. For x is 0, this exists, both are equal to 1. And for x close to 0, this is slightly less than 1. And this fraction is slightly greater than 1. And this fraction, x divided by sine of x, is a function that goes somewhere here in between. So, if we know this result, we can consider the following function. It is called cardinal sine, spelled S-I-N from sine and C from cardinal. And this function is defined by the two results, or two formula. It is equal to sine of x divided by x, for x is different from 0, and it is equal to 1 for x is equal to 0. And if we sketch the graph of this function, then sine alone oscillates like that. For growing x, we have a function that oscillates between -1 and 1, and we divide by larger and larger numbers, so the wave has lower and lower amplitude. And for x goes to 0, this function approaches 1. And it is a ratio of two odd functions, so the resulting function is even. The graph is symmetrical with respect to the y-axis. So this is the graph of the function sine of x divided by x alone, and this function alone is not defined as 0. This point is not part of the graph. But if we have this limit, we can define the function this way. So in this dangerous point, we say it is equal to 1. And that means that we we delete this empty void, and we can consider a function defined for all real x, which is now continuous everywhere. So that was one application of the squeeze theorem.